Well, this session will be on trigonometry, and so we'll go through different points really of 2-unit and some 3-unit trigonometry. First thing is, what is a radian? A radian is the angle at the centre of a circle, an angle at the centre of a circle subtended by arc equal in length to the radius. So you've got both of those, all those are equal. That's what a radian is. First of all, you've got to know in connection between degrees and radians is pi radians is 180 degrees. You've got to know what pi over 2 is, pi over 3, pi over 4, and pi over 5, pi over 6. And always remember it in those terms, and you get multiples of those. For example, that's 90 degrees or 60 degrees or 45 degrees. The next thing is pi over 5 is 36. Don't forget 2 pi over 5 is 72, pi over 6 is equal to 30 degrees. Next part in anything to do with trigonometry is dealing with triangles. And in a simplistic way, I see triangles divided into two types of triangles. There's a right-angled triangle and not right-angled. And all the sums that you can get in triangles can be divided into that context. Now, if you take right-angled triangles, in a triangle there's three things to look at. Is the side, the angle, and the area. The area of a right-angled triangle is half the base by the perpendicular height, and the angles, and this is where the trigonometry or trig ratios come in, that you could have A, B and C, and that sine theta is equal to the opposite over a hypotenuse, etc. So the trig ratios are sine, cos, tan, the reciprocals, cosec, sec and cot. The triangles that we really concentrate in the work in 2-unit mathematics is the triangles which are not right-angled, and so the situation of knowing the sides, angle and area have to be worked out. Now, first of all, area of a non-right-angled triangle is put down as in this half AB sine C. Now, what that really means is if you've given an angle, you're given an angle in a triangle, and you're given two sides, and that's an included angle. So when you look at the formula, you must know that side, and the angle. So this is half AB sine that angle there. What you look at is two sides included angle. The other part, when you have to look at sides and angles, you use the cos rule or the sine rule. When do you use the cos rule? The cos rule is you want to find a side or you want to find an angle. Now let's investigate that. If you're given two sides and you're given an included angle, you can use the formula c squared is equal to a squared plus b squared minus 2ab cos c. In other words, you need two sides and an included angle to find the other side. The other part of it is that you're given the three sides. Now, if you're given three sides, you can find an angle. I'll just repeat that again. You're given two sides and an included angle, you can find the third side, or you're given three sides and you want to find an angle. Cos c, c is the unknown now, this angle here, is equal to a squared plus b squared minus c squared over 2ab. Other part, they're the two aspects of the cos rule. You're given two sides and an included angle, you want to find the third side, or you're given three sides and you want to find an angle. Sine rule is used when you're given two sides but not an included angle, and you want to find another angle, or alternatively, you're given two angles, which means you're given three, and you're given a side, and consequently you want to find the other side. Next part is trig ratios, the relationship or trig identities. Instead of trig ratios, we'll call this trig identities. And the trig identities are all connections between sine squared, cos squared, sec squared, cosec squared, cot squared. The relationships are that sine squared theta plus cos squared theta is equal to 1, sec squared theta is 1 plus tan squared theta, and cosec squared theta is 1 plus cot squared theta. This particular sum, the expansions of these sine A plus B all have to be known. There are 6 of them. The first one, sine A plus B, is sine A cos B plus cos A sine B. Sine A minus B is sine A cos B minus cos A sine B. Cos A plus B is cos A cos B minus sine A sine B. Cos A minus B is cos A cos B plus sine A sine B. Tan A plus B is tan A plus tan B over 1 minus tan A tan B. And lastly, tan A minus B is tan A minus tan B over 1 plus tan A tan B. Next part in this work is double angles, and sine A or sine 2A is equal to 2 sine A cos A, and then you've got cos 2A, or 2, let's put down 2 theta. Now the 3 forms of this cos is cos squared theta minus sine squared theta is equal to 2 cos squared theta minus 1 is equal to 1 minus 2 sine squared theta. Now, it's interesting, in some of the sums that you will get in 3 unit, might be this sum here. What's the integral of sine squared theta? Well, you have to change this integrand into something you can. The only trig you can do, you can integrate sine 2 theta, you can integrate cos 2 theta, you can integrate sec squared 2 theta, and if it's not one of those forms, you have to change whatever the integrand is here into something that you can integrate. Now, you must learn it in this way. So if you take these forms here and manipulate, put the one over the other side, what do you get? You get from there, if you can look at it, 1 goes across here, you get 1 plus cos 2 theta over 2. In other words, cos squared theta is equal to 1 plus cos 2 theta over 2. And sine squared theta, if you do the same thing, is equal to 1 minus cos 2 theta over 2. They must be known. These are very important 3 unit. So this form here would be equal to 1 minus cos 2 theta over 2. You can take the integrand half out in front, and consequently that becomes a half into, if you leave half out, becomes theta minus sine 2 theta. Now, differential of that, of course, becomes 2 out, so you'd have to put a half here, plus the constant. This sum is asked numerous times in the HSC. The question that also is common in the HSC is the angle between 2 lines, and the formula is given by here. Tan theta is the absolute value. Absolute means that we disregard the sine, and we're just interested in the acute angle here. If you took the other angle, negative angle, and tan is negative, you end up with the obtuse angle. So we're only interested in the acute angle. What you need in this is y equals, for example, y equals 2x plus 7 and y equals x minus 1, and so you're interested in the 2 slopes of the line, so you just say, well, m1 is equal to, in this case, 2. To find the slope of a line, you must say, put it in the form of y equals mx plus b, and the slope is, in this case, 2 of that line. You can call that L1, and the other one is L2. The slope of this particular line here is equal to 1. You substitute that both into the formula. Notice here you've got 3 unknowns. You've got m1, m2 and theta. So the questions would all vary around 3 unknowns. You need 2 to find the third one. In this case, you're given the two gradients, you need the angle. You could be given the angle and a gradient to find the other angle. Find the angle and the gradient to find the other gradient. You're going to do the differentiation and the calculus and the integration regarding trig functions or trig ratios and so forth. You have to have limits, and you use first principles. They possibly wouldn't ask first principles dealing with trig. But the one limit they do test to know is the limit of sine theta divided by theta, and theta's in radians, as theta tends to 0 is equal to 1. Now that has been asked. I'll give you an example in 2002. This was the first question on paper 2002 HSC question. The limit of sine 3x over x as x tends to 0 is equal to, now you must change this form into sine theta form over theta as theta tends to 0. Each of those has got to be the same. You can't do anything with 3x, can't take it out. So we'll just manipulate sine 3x, you'll put 3x here, and if you put a 3 there, you'd have to multiply by 3 because they would cancel out as x tends to 0. So now, note, as x tends to 0, if x tends to 0, then 3x tends to 0 also. In fact, it goes to 0 quicker, so we'll change that. We'll put this over here to explain to the examiners what we're doing. So it's 3x tends to 0, so that's the sine 3x over 3x by 3. And the limit of that 3 can be taken out in the front. This is 1, the answer is 3. Solving trig equations is the most important topic in 2 and 3 unit or extension 1 maths. One particular question might be something like this: sine theta is equal to 0. Now once you must know, you could draw these diagrams here. Say that the tan of 0, the sine of 0 is 0. The sine of pi over 2 and 90 is 1. The sine of 180 or pi is 0, and the sine of 3 pi over 2 or 270 is equal to minus 1. Sine of 360 is 0. The cos of 0 is 1, cos of 90 is 0, cos of 180 is minus 1, the cos of 270 or minus 90 is equal to 0. And the last one, of course, is tan. And the tan of 0 is 0. The tan of 90 is undefined, that's no value. The tan of 180 is 0, and the tan of 270 is undefined. They are most important to put down that way, and it helps in a lot of sums. Another part is for argument's sake, let's make a sum up. Sine theta is equal to a half. Now this is an elementary question, just to find what theta is plus a half. In this sum here, you would have to be given a range of values. Let's take, for argument's sake, theta. They want you to find theta between 0 and 2 pi. If they leave that out, that particular range or domain of values you're going to use there, then it becomes the general formula. Now, in this particular sum here, if you use your Pythagorean triad type of thing, you obviously know that pi over 6, pi over 330 degrees, and the sine of pi over 6 is a half, and because that's plus, that means that plus there would indicate that theta is in the first quadrant and the second quadrant. So it's in the second quadrant, as you know, it's ASTC, and its sign is positive in the first quadrant, the second quadrant. Consequently, this is pi minus pi over 6. Pi is 6 pi over 6, take away 1 pi over 6, becomes 5 pi over 6. In this sum here, we've got sine squared and we've got sine 2. This was asked in 1992 HSC. Solve that equation, find out what theta is. So if you've got theta and you've got 2 theta, clearly you must try and make it all thetas. And so what do you do? Well, you can't do anything with sine squared. You've got 2 theta, and you know that sine 2 theta is 2 sine theta cos theta. Take this over the left-hand side, and the 2's will cancel out on both sides. Take that over the left-hand side, and you'll find that sine theta into sine theta minus cos theta. So now you've got a product. That by that is equal to 0, so therefore sine theta is equal to 0, or sine theta minus cos theta is equal to 0, which means sine theta is equal to cos theta, and divide both sides by cos theta means tan theta is equal to 1. This one here, of course, as I said a minute ago, if you have sine, the sine of naught is naught, so theta, and this is up to theta between naught and 2 pi. So sine theta would be 0, or it could be pi. And notice it's in terms of radians here, so we've got to put in radians the answer. So this would become naught, or pi, in this case goes right around here to 2 pi. So there's 3 angles there that have to be put in. Tan theta is equal to 1. You go back to your right angle triangle again, 1 root 2 and pi over 4. So in this particular case, theta, and that's plus 1, so it's in the first quadrant, which is pi over 4, or it's pi plus pi over 4, which is 5 pi over 4. They're the 5 answers in that particular sum.
3, 2, 1.
Now, another type of trig equation might be called a quadratic trig equation. For example, if it's sine squared theta plus 3 sine theta plus 2 is equal to naught, we can treat that like any quadratic equation in terms of sine theta. You could, some people might put u equal to sine theta, and you get u squared plus 3u plus 2 equal to 0, and find out that what u is equal to, and you can fairly simply see that u is equal to minus 2 or minus 1. And so sine theta would be equal to that, or sine theta is equal to minus 1. Now minus 2 is outside the range of values, so there are no solutions in that sum there. If you draw the graph, clearly it shows, you draw the graph for here for sine theta, if I take it like so, and you put that's 1, and you draw a line across 2 where y is 2, doesn't cut, so there's no answers for that one. This one, when sine theta is equal to 1, we go also back to this original thing here, and the answer is minus, sine theta is minus 1. Minus indicates that it's got to be in the third quadrant or fourth quadrant. In fact, the only answer for this one in a range from 0 to 2 pi with theta would have to be equal to 3 pi over 2. So that's called a quadratic. Now you don't have to introduce u, you can just put it down quickly in terms of sine theta there, but that's the type. Okay, just to revise very quickly, this was a question in 1998, is the limit of sine 3x over 5x. This is HSC questions. You'd have to have 3x on the bottom here, you put the 5 out, you put 3x, and the 3 would have to come here, so it would be 3 over 5. You must 3x, and you change as x tends to 0, 3x tends to 0, so we could do that. Notice the one above it also, HSC question, find the acute angle between the two lines. You know the slope of this line, the gradient of this line is 5, you can call it M1 or M2, it's irrelevant. And the gradient of this must make it y equals mx plus b, so it's y equals 2 over 3 plus 8 over 3, but it's the 2 over 3 is the gradient of that line. And the third part that I mentioned too is the bottom part of this question is the limit from 0 to pi over 3, but it's sine squared. We can't integrate sine squared. We have to change that into something we can integrate, and sine squared, you must know this formula, is equal to 1 minus cos 2x. In this case it's x, 1 minus cos 2x over 2. So you change that integrand into 1 minus cos 2x over 2. This particular sum is also 1992, it's question 3, and this is another form when you've got sine 4t plus root 3 cos 4t. You can't collect your terms for that. You can't collect sines and coses. So here, and it says here, put it in the form. In the form means equal to this part here. You've got to find In other words, you put all of this expression here into that form. You've got to find out what r is, and you've got to find out what alpha is, and they call this auxiliary angle or subsidiary angle method. Now, there are various ways of doing this, but sine 4t plus root 3 cos 4t, you could say that's equal to, if I put a 1 here, which is 1 in front of that, and I put a 2, if I put a 2 under here and a half under there, I'd have to multiply that all by 2. I hope you're seeing what I've done here. 2 a half gives 1, which was there, and 2 by that 2 cancels out, and you've got the 3. Now, why do it in that form? So it becomes 2. Now, in this particular thing here, we're going to make a half, and so we come back to this triangle, root 3, 2, 1. Now, in that right angle triangle, root 3, 2, 1, I've got a half and I've got root 3. So I'm going from a half. What is a half? It's a strange way of thinking about this, but what is a half? A half is equal to, in this particular triangle, is equal to the sine of pi over 6. We normally say sine pi over 6 is a half. I'm saying a half is sine pi over 6. We take a sum like this, again, we can't get sines and coses together. And when I don't have any root signs in front of it, like the previous one had a root sign, there's another method called the t method. And sine theta is equal to 2t over 1 plus t squared, and cos theta is equal to 1 minus t squared over 1 plus t squared. In other words, you now get the unknown as t. By manipulating that formula there and cross-multiplying, you can work out what t is, and consequently now we all know that t is equal to tan x over 2. This is called the t method, quite useful in solving sums also. Now, if I just have a look at another question that might be of interest to us, is this particular one here on the bottom. And what does this say? Starting with this identity, and this is using all the work we've just been talking about, the identity of that. It doesn't say starting with it. It's not asking you to prove that. Use that. So it's a sine A plus B. A is theta and B is 2 theta. Well, using that. Now, if you've got sine 3 theta, it says, and using the double angle, prove. Well, you take one side, and you've got here. Now, clearly, you've got the left-hand side is sine 3 theta, which is equal to that. And then, therefore, it's pretty obvious that sine 3 theta is this. You've got cos 2 theta and that. Now, you've got to put all this in terms of theta, or in other words, sine theta or cos theta. In this terms of sine theta, you change this into 2 sine theta cos theta by cos theta. So it's 2 sine theta cos theta, and multiply that is 2 sine theta cos squared theta. Now you've got cos squared theta, don't forget, cos squared theta plus sine squared theta is 1, or cos squared theta is 1 minus sine squared theta. So I manipulate all in terms of sine theta. This one here, you've got 3 forms of cos 2 theta, and you must make it the sine form, so this part would become 1 minus 2 sine squared theta. That part, and you manipulate it, you get that. Look down here now, the equation here, this is all worth 5 marks. Sine 3 theta is equal to, hence solve that quotient. Well, you know what sine theta is, even if you didn't be able to prove that. You put this part down as the sine 3 theta, you got 2 theta, you can take sine 2 theta over the other side. Hope that makes sense then. You use that sine 3 theta, you put this form into here, and you solve for sine theta.